Okay, guys, I'm starting IP addresses. I will give you a few details. So then, if you read it once, tomorrow it is very useful again. Better you will understand. Okay, so this is IP address part 1. What is an IP address? It's a logical address which we discussed earlier. IP address is nothing but a logical address. Okay, and also we can say IP address. So uniquely I put a uniquely identify a device in a in network. It means every device is in a communication in a network should have a IP address that is uniquely identify a device, not a unique address. So I want to identify a device separately. So that is we required an IP address. Okay, it's numerical. It's a numerical as what are the spelling it is. It's a numerical representation of an IP. Okay. In IP addresses in general we are using IPv4 we are using, and also we are using a IPv6. So by the way, I will tell certain differences of IPv4 and IPv6 also. IPv4 is a 32-bit. One second, yes. Hello. Purpose? Not required. No requirement. No. Okay, it's a 32-bit. So this is 128-bit IP address. Okay. So whenever they started a build a IPv4 address in a public, similarly IPv4, IPv5, IPv6 start building. But IPv4 finish earlier than IPv6, so then IPv4 is released. In IPv6 and IPv5, in the research they found IPv6 is having a more benefits than IPv4. Okay, security wise IPv6 is more secure than IPv4, and more number of IP addresses we are getting here. Okay, so 32 means 2 to the power of 32. 2 to the power of 32 IP addresses we are getting here. It is almost like a 4.3 billion IP addresses we are getting. In IPv6 is 2 to the power of 128 IP addresses we are getting. It is almost like 3.8 into 10 to the power of 38 IP addresses almost we are getting. It means it's a billion billions of IP addresses we are getting here. It's a limitation is there. IPv4 has a limitation like a 4.3 billion maximum. But here billions of IP addresses maybe in a future because of the world is getting a more population, and as well as we have a lot of devices. See, um, we are one person one IP concept, then definitely maybe work. But if you see, I have a mobile phone, I have another mobile phone, I have a laptop, I have a desktop, I have a Kindle. So totally at present in my system in my room, I'm staying here single present currently. Okay, two one desktop, one laptop, two mobile phones, and one Kindle, and of course my owner and my next room person also using my internet sometimes. Okay, so if one single network I am using almost 4 5 IP addresses, right? Think in the world how many IP addresses are there. For example, my sister home, one laptop, two mobile phones, guarantee, and my brother-in-law again one laptop, two mobile phones. In my hometown, like one TV also there, one TV also we are getting internet, right? So IP addresses are not enough. In a future, maybe we will get another thing. Of course, there is a lot of solutions are given by IP address people, but still we have to move on from IPv4 to IPv6. So then multiple devices we can directly connect it through internet. Okay, we are not directly connected to internet. We are connecting through a router. That's why we have a we are using a lot of IP addresses in. So that point I will tell again because that is we have to understand public private kind of stuff that that time I will tell. Okay, iana icann. So search in internet what is these things. Okay, iana icann is organizations. Iana and icann are an organizations who are authority assigning these IP addresses. What IP address, what purpose of IP addresses, what MAC addresses, all these things will be maintained by iana icann, including DNS names. Like you want to create a same address as a website, you cannot create. Why? Because of it is a rules and regulations we have to follow like this. Okay, so that is one thing. So IPv4 is a 32-bit, IPv6 is 128-bit, not 64. Remember, if it 32, 128. Okay, this 32-bit IP address is divided into four parts. Is divided into four parts. Okay, IPv4 means one single IP address, 32-bit. A single IP address is divided into four parts and separated with a dot. So this is we always tell dot. Okay, so separated with a dot. Okay, so each part we call it as a octet. Each part we call it as a octet. Why octet? So we'll see that one. It's a 32 bit, right? So I divide into four parts. It means we got 8. 8 means 8 bit. Each one is 8 bit, like this. First part 8 bits, second part 8 bits, third part 8 bits, fourth part 8 bits. Okay, so 8 bit, 8 bit, 8 bit, 8 bit. What is a bit? 8 bit means what? 0 0 0 0 0 0 0 0. 8 zeros starting, and next 8 bit, sorry, 1. So in generally numbers are there, no, 1 0 3 like that. So bitwise 1 in one single part I am telling, not all parts I am telling you. So it's one any one of the single part. 8 bit means like this it will go. It keep on going. Okay, it will keep going. Finally, we reach the final part. Okay, finally we reach like this. I'm writing last two. So this is the 8-bit completion. This is one single 8-bit, one single 8-bit, 8-bit completion. Starting is 0. Yeah. Okay, luckily we got a water here. In my record, everything is mixing now. Okay, so the first value is nothing but a, in decimal wise, it's a 0, and the last value is nothing but a 255. The last but one is 254. Okay, like 1, this is actually I will start always IP addresses with the decimal to binary transactions, but I'm not starting now. Okay, if you are not at all familiar with the binary to decimal, definitely I will tell that one, but tomorrow I will tell that one. So tomorrow, I think a lot of people are still sleeping. Okay, so 8-bit means it's to start with a 0 and with a 255. It means all these octets either 0, 1, 2, 3, 4 up to 255. 0 to 255 is there. So because of its 8-bit, it called as a octet. Because of its 8-bit, this one is called as a octet. And while we are writing a IP address IPv4, we write in a decimal format. So we write in a decimal format only. But in IPv6, we write in a hexadecimal format. Okay, it is a binary number, but it is we write in a decimal format only. IPv6 write in a hexadecimal format. Okay, so it is a 4. It is IPv total 32-bit IP address divided into 4 parts. 32-bit IP address is divided into 4 parts. Okay, each part is separated with a dot. Okay, because of you divide it to the 4 parts. Okay, each part is 8-bit. Because of its 8-bit, we call that each part as a octet. It means first octet, second octet, and third octet. It's a first octet. So I put a, yeah, first octet, second octet, third octet, then fourth octet. Okay. Hmm. So this is the thing. So first octet, second octet, third octet, and fourth octet. Each octet is 8-bit. So 8-bit start with a 0 and with a 255. So this is about your thing. Okay. So the size is 0 to 255 dot 0 to 255 dot 0 to 250, like this. So in any octet, you can't get more than 255. You can't get a more than 255. So that's keep in your mind. Okay. Example of IP address. Example of IPv4 is like, for example, 192.168.2.224. This is my something 114. So this is how IPv4 is look like. Okay. In a IPv6, okay, we have to type like it's a hexadecimal format, 128 bit, 128 bit. So this 128 bit, so divided by 8 blocks, 8 blocks. So each block contains 4 hexa numbers. Sorry, we'll go with a uh, different way. A different way. 128 bit. So 128 zero ones. 128 bit means 0 ones or 128 are there. Hexa means, sorry, where it is. What is hexa? Each hexa, each hexa is equal to 4 bits. First of all, each hexa is 4 bits. Okay, each hexa is 4 bits. Means if you put a 8, it means 1000, 100. That is the value, hexa value. A value is 1010. For example, 20010. Compulsory, we should use 4-bit value only. Each hexa in one single hexa number represent 4 bits. I got 128 binary and 4 bits. So how many hexa numbers we are getting here? 128 by 4, 64,
32.
32. Very good. So 32 hexa numbers are there in a IPv6. So see how much big it is. Okay. So you have to write 32 thing. So this 32 hexa divided into 8 blocks. 8 blocks. So how many blocks are there? 32 by 8. No. 4 blocks or 8 blocks? 8 blocks. Yes. So each block contains 4 hexa numbers. 4 hexa numbers in each block. Okay. So this is it. I'm going to write an example of a IPv6 address. Just 2002 anything 111 222 333 anything like you can write um, aaaa bbbb ccc uh, dddd. Anyway we can write it, but I write in like this. It's a global unicast address, some unique address. Okay. So this is how it is look like, how our IP address is look like this. Okay, in a decimal format. This is the example of a hexadecimal format. Okay. This is a block wise, this is this wise, that's why it is given very big length. Okay, so this is about your IPv6, and still some more things are there. Okay, in IPv4 you have a unicast type of addresses, multicast, and broadcast. Unicast, in IPv6 also you have unicast, multicast, and no broadcast. It is having a anycast. That's why it is a different. In a unicast, again, unicast in a IPv4, we have a private addresses, public IP addresses are there. In a unicast, also same thing. Like in a unicast, they use private IP address as a link local IP address. So within the local IP address only, within the LAN communication. When you communicate WAN communication, then it is global unicast address are there. Okay. Local host or what is a local host or a loopback address of IPv4 is this one. Okay, here in IPv6 it is colon 1. Okay, so there is a reserved IP addresses also there, like 0 0.0.0, this kind of stuff is represented as a colon colon only. So remaining ranges we'll see, depends, but at least few differences you must know, like a unicast, multicast, broadcast, unicast, multicast, anycast. Here it is private and link local, public, global unicast, localhost 127.0.0.1, and localhost is colon colon 1, and there is a special reserved IP address is there in a different purposes they use, that is 0.0.0, and this is a colon colon here. Okay, different ways of doing IPv6 is there that we will see later, but this is about your basic idea of IP addresses. Next, IP addresses. Range of IP address is 0.0.0.0 to 255.255.255.255. This is the total range of IP address. IP address, IPv4 address is 0.0.0.0 to 255.255.255. So if you write an IP address like this, starting IP, next IP, 2, 3, 4, 5, like this. It is continuous. It is continuous. And it will go, for example, 0.0.0.254. 254. Now 0.0.0.255 reached. Then what will happen? 0.0.1.0. It will become like automatically 255 becomes 0 and it is 1. To understand, I will give you a very simple example. Try to understand. After 9, what number? 1, 0. Right? We'll go with 1, 2, 3, continue, and 9, 10. Then 19. After 19, you will get a 20. 29. After 29, you will get a 30. Right? You go 99. Then obviously 100. So, because our decimal system highest number is 9, once you reach the 9, automatically 9 become 0. 1 will be added to the previous one. Right? Same thing like 199, 200, 999, 999, 1000. See what happening? So same thing will be happen to our IP addresses also. So once it is reached 255, what is the next number? 10. Again it go on 1.1, then go on. It reaches 0.0.1.255 reached. Then what happened? 0.0.2.0. It keep on going. It keep on going like this. Okay? It keep on going like this. Finally, it reaches 255, 255, 255, 255. Total 4.3 billion IP addresses it will reach. If you want, I can type so many things. Okay, till it is covered like this. Okay, otherwise you will go 0.0.255.255. Then go to 0.1.0.0. So like this. Next one. So 0.1.255.255. So 0.2.0.0. 0.255, 255, 255. Finally, you will get a 1.0.0.0. After 1 dot, this one, and you will get a like this. Means it is keep on going. So finally, anyway, and last you will reach this one. What happened? I got a sound, but I thought someone posted a question. a WhatsApp message. People will tell Sunday, Sunday. Last 1 month and my brain is not working. We'll we'll see tomorrow whether Sunday we can able to put or not. We'll see it. Okay. So currently try to understand this one. IP addresses 0.0.0.0 to 255.255.255 and 0.0.0 and it is continue from there to here. Okay. So like a 1 2 3 4 how it is there same thing it is fill up to here. This is the total number of IP addresses. Okay, from here to here. Next, think like this. If I have a IP addresses normally I have an IP address. That's an IP address I have. Okay, I start giving IP address to each and every PC. How many PCs I can able to give? 4.3 billion IP addresses I can able to give. Problem is, okay, so problem with that one is once 4.3 IP addresses completed, so I can't assign IP address to anybody. 4.3 is a very small number as per now, okay, because of what is our population is 1.3, right? As per I said, at least in India itself, we are using a more than 2 million IP addresses we are using. Okay, and of course, what about other countries? Already, all other countries are crying on us like we are in a this kind of condition. So India and China combinedly use all the IP addresses. We have a total 7.5 billion people are there, out of which 50% India and China is occupied. Luckily, India and China is doing very good on their own self. That's why we are no need to depend upon anybody. Okay, so this is uh, complete range. You know, so instead of that one, so they want to make certain changes. Later we'll understand why we are dividing other advantages of dividing it. So last time they got a question why IP address divided in classes. So this is a question they asked last year batch question why IP addresses are divided in classes. Why IP addresses are divided in classes. This is the question the last time they asked. So why it is divided? Because we have a 4.3 billion IP addresses and we can't assign each and every IP addresses like that. So we divide IP address into the network and host portions and we can utilize the IP address and IP networks in a best way. Okay, so that's why we are divided. But how many divisions are there? We divide into class A, class B, class C, class D, like that. So five classes we divided. IP address is divided into five classes. Okay, how to identify the class is if you see the any IP address, the format is like this. Okay, here the first octet, the first octet of the IP address will be decide which class it is. Okay, the first octet will tell you what class it is. That's it. Okay, so here is the class ranges: class A, class B, class C, class D, class E. Class A range start with like this binary number, all zeros, and end with sorry. The first zero is we have to keep it. Remaining we should make it as a ones. That's it. And the range is 0 to 127. But if you verify certain test book, it's a 1 to 127 only. Class B is what is the next number is 128. Okay, and we have to keep first 1 and 0 same. 1 1 1 1 1. Just they divide like this using a simple technique. The range here we have to write 128 to 191. Okay. Mm. You no need to remember the binary things. Okay. If you know binary things and you are try, I will tell you how to remember how to do this one. But otherwise, just for notes only I'm giving. You have to remember these ranges compulsory and why it is 1 to 126 instead of 0 to 127. So that is also I will tell. But currently, go for this one. 1 1 1 0 1 1 1 224 to 239. Okay, 1111. Sorry, 0 0 0. So 240 to 255. So this is the complete range. Okay, here unicast are class A, class B, class C. Multicast. So those are a thing. But first three classes are a unicast IP addresses. This is a multicast IP address. Okay, this is the multicast. And class E, we don't use at all class C. So that is for a R&D purpose only. It's not a broadcast. It is a R&D purpose only. So in a certain organizations or internal organizations, iana I can reserve this for some different purposes. So we don't worry about this. What is the purpose of this one? So it is special purpose. I'm not going to dig into it. So leave just like R&D only because test books and no one is telling what is the use of this one also. Multicast is using in a certain multicast way, like a communication within a certain protocols like class D. Multicast is used to remote, like a WD service, like a deployment service, remote deployment through network or a remote deployments. You can say deployment or a remote deployment. Okay, certain protocols like routing protocols. So certain routing protocols like EIGRP, RIP version 2, RIP version 2. So OSPF, like certain things will use multicast addresses in a specific purpose. Okay, of course, normally multicast means group communication. So if I post to a person, for example, yeah, if I post a message here, only this person will get the message, right? So if I post a message in the group, those who are in the group only get message, not everyone. Okay, so like that, certain messages are broadcast messages sent to everyone. Broadcast means to send to everyone. Multicast means within the group, those who are in the group, and unicast means one-to-one communication. Okay, so this is the ranges of classes. Hmm. That's it. Tomorrow, I will tell what is a network portion and what is a host portion. Okay, and what is a subnet mask. Okay, what is a subnet mask and other things. Okay, subnet mask, default subnet mask, private IP addresses, public IP addresses. Do it. But I want to give you already I given exercise yesterday, but I don't know whether you done or not. This is one question: why IP addresses are divided into the classes? Find out in the internet. Second one is port numbers. I want everybody to you should tell. I will ask randomly one or two people or three four people. So you should tell name and port number. You should tell name and port number. Okay, and you should tell OS layers and then port numbers. Data in the data format in a transport layer, network layer, data link layer, and bitstream. Sorry, in physical layer, data formats. So understand the question. So port numbers, OS layers, um, why IP address is divided into classes. Next one is um, data formats in a OS layer. Data formats in a OS layer. That's it. Of course, class ranges. These ranges required. These ranges required. Okay, these things study, compulsory study, and then we'll ask tomorrow randomly. I don't know to whom I will ask. We'll see tomorrow morning. Okay, guys, morning again, 10 o'clock. Meet you there. 10 means, guys, 10 means don't log in at 10. Log in at 9:30 or after 9:30. So log in at after 9:30, 9:30, 9:45. Okay, at least by 9:45. Try at 9:45. We'll see everybody came. Then I will start. Otherwise, some people missing. So that's not at all good. Recording is not for everything. Okay, recording for a saving for repeatedly to look at that one. So that's the only thing. But I don't record mostly in a starting point. So this is it, guys, for today.